Welcome, and thank you for joining our webinar, What's Hiding in Your Code? Uncovering the State of Code Security. If you have joined any of our previous webinars, hello again and welcome back. And today we'll be asking the question, what if you could pinpoint the most common security vulnerabilities and hotspots lurking in source code before they reach production? I'm Andrew, and I'll be your moderator today. And I'm excited to have Anirban Chatterjee, Director of Product Marketing, and Lauren Hanford, Director of Product Excellence, who will be presenting today. But before we begin, let's just quickly go over some housekeeping points. So the session will last around about 45 minutes, including a time for Q&A at the end. And you are invited to submit your questions at any time during the webinar via the Q&A box in Zoom. So don't use the chat box, use the Q&A box and submit your questions at any time. That's because behind the scenes, we have Robert Curley, one of our product marketing managers, joining us as a panelist who will be standing by from now, ready to answer your questions live throughout the webinar. So welcome and thanks in advance, Robert. The session will be recorded and we will send out a link to the recording via email in the coming days. And a quick heads up, there will be some polls during today's webinar, so please do participate. The more people that do, the more interesting the results. And finally, there'll be a brief survey at the end, so we appreciate your feedback in advance. Now, I'm pleased to introduce our presenters. Our first presenter is Anirban, a product marketing leader with over 20 years of experience in the enterprise software space. He began his career as a software developer at IBM, giving him a powerful foundation in the challenges developers face today. At Sonar, Anirban is now focused on helping companies boost the value of their software assets to accelerate their business growth. Our second presenter is Lauren, a product leader with deep expertise in the critical field of open source software supply chain technology and developer tools. She joined us at Sonar following the acquisition of Tidelift earlier this year, and now focuses on coaching our product teams to deliver exceptional outcomes for our customers. Anirban, I'll hand over to you. And I think you're on mute.
You think I do enough of these Zoom calls, huh? Thank you, Andrew, and thank you, Lauren, for joining me today. I'm really excited to be covering this topic with everybody. There's a lot of interest today in assuring the security of our code base, assuring the security of our source code. And the research that Sonar did this summer is some of the most interesting proof points I've seen thus far that show just some of the top issues that just come up over and over and over again. And I think it's an interesting exercise to kind of walk through that with you all and show you just some of the key things that that seem to occur in source code very commonly. And it's particularly relevant now in the age that we find ourselves where we're actually using AI to write more and more code. So we are going to cover today, what is the cost of poor software quality and security's impact on that? We'll talk about the state of code reports that these findings come from. And then Lauren is going to take us through the top vulnerabilities, the top security hotspots, and the most frequently hard-coded secrets we find in the analysis of the source code that Sonar does. And then finally, we'll touch on some other topics like software composition analysis and the impact that this all has on AI coding. And as Andrew said a few minutes ago, if you think of questions that you have during the course of the presentation, please avail yourself of the QA box, which is in the toolbar on your screen, to ask those questions, and we will either answer them in chat or we'll try to answer them live if we think that the broader group will benefit from hearing the answer. I want to start, though, by talking about the engineering productivity paradox, which is a concept that we at Sonar have been talking about for a little while now. And it's this gap that is continuing to increase between the volume of code that is being generated by AI and the scale and the resources and the time available of the developers that are managing all of the source code that they're responsible for. And that gap continues to increase with time because AI is just becoming more more prevalent and more productive in the source code that it is generating that is being committed in code bases for, by organizations around the world. But without a verification check to make sure that the code that is being generated by AI code generators, making sure that it's high quality, without that level of assurance, you run the risk of destabilizing your code base. And skipping code review or having a light code review on AI generated code, or even human generated code that was assisted by AI, has downstream consequences that are only going to increase as this volume of code that we are generating increases. We already know, based on research by CISQ, that the cost of poor software quality is already quite high, even without taking AI coding into account. In 2022, the total cost of data breaches was $4.35 trillion just in the US alone. The cost of poor quality software was 2.4 trillion of that. And so that poor quality can come from a variety of things. It comes from bugs, software bugs that impact reliability of the code. It comes from security issues that impact, incidents that leak data and cause customer data to spill out on the internet, and maintainability issues or code smells that would actually impact the maintainability of the code, the ability for developers to actually understand the code base therein and be able to quickly and productively make changes or additions to it. And so those of you who are already Sonar users will know that SonarQube was created by and large to help developers address and meet this challenge and solve this problem. And so we approach this problem in three stages, really. First, we help developers analyze the code architecturally, from a quality perspective, from security perspective, and we actually have code quality and code security capabilities within the product that are integrated together to help developers do that. We also assist in the review process, the code review process, to help developers not only define, but also apply and in a standard way enforce those quality standards that the organization has agreed are important to follow into the source code. So every time you're pushing new code, you're following the same rules every single time. And then finally, the action phase. Like if we do find issues, what do we do, right? And obviously, there's a lot of built-in guidance within SonarQube to help developers understand what the nature of the issue is, along with guidance on how to solve that issue most efficiently. And for many of these issues, we actually have AI code fix in the product now, which actually suggests using an LLM suggestion, a fix for the code issue that's come up. So if you're on one of the latest versions of SonarQube or if using SonarQube Cloud, you already have access to AI code fix, which allows you to generate automatic fixes for many of the issues that come up frequently in source code today. So we'll be focusing on the security component today. Sonar looks at code vulnerabilities and code security hotspots, and we've had security features within the product for a very long time, as many of you are aware. And we also just recently launched advanced security, which we'll touch on later in the presentation. But today, we're primarily focused on the research that Sonar has done most recently around the state of code. And as you may know, Sonar divides or categorizes different quality issues in source code in three different ways. There's reliability issues that deal with bugs. There's security issues that deal with vulnerabilities and security hotspots. And there's maintainability issues that deal with code smells. So we have a report for each one of those three available on our website today. You can see the URL on the screen right now if you want to go and download and read any of those reports. And there's also a fourth report that breaks down quality issues in all three categories across the top languages that developers use today. And we'll talk about those in a second. But if you are just curious, if you're a Java developer and you want to know the top issues that are available in Java, and there's literally a chapter for Java and JavaScript and other languages in that languages report that you can go get. So all four of those reports are available today. Free download, just go to our website and you'll see them. But today, we're primarily going to be focused on the findings in the security report. And the security report, as I mentioned, focuses on hotspots and vulnerabilities. But the overall project that we undertook this summer was taking a block of source code that was analyzed in SonarQube Cloud over a 6-month period during the back half of 2024. So July to December of 2024, we looked at all of the source code that was analyzed in SonarQube Cloud in 7 of the top languages the developer is using today. And those languages are Java, JavaScript, TypeScript, Python, C++, C#, and PHP. So all 7 of those languages were included in the data set that we analyzed to create all four of these reports, which amounted to about 7.9 billion lines of code, all told, about 970,000 developers worth of work, and across 40,000 organizations distributed globally. So this is a worldwide analysis that we did. And when we did that analysis, we found that SonarQube surfaced about 445 million issues across all three quality, categories. So quality, that's reliability, security, maintainability. 445 million code issues were surfaced by SonarQube during that time. And we fired about 5.3 thousand unique rules or code issues, again, across all three categories in that time as well. So what does that mean for security? Time for our first poll. So I would like you all to hazard a guess as to how many security issues, and that's vulnerabilities and hotspots grouped together. How many overall security issues do you believe SonarQube found per million lines of code we analyzed as part of this data set? So you should have a poll on your screen right now. I'll go ahead and give you guys a minute to put in your guess. Okay. It looks like most of you are quite pessimistic. Looks like half of you thought that it was answer D, 10,500. I have good news for all of you because the answer is actually answer B, 1,200, which is actually lower than I thought as well. So 1,200 security issues per million lines of code analyzed across vulnerabilities and hotspots. And maybe it makes sense for a moment to kind of define what those two things are for those of you who aren't familiar. A vulnerability is basically a clear and present danger in your code base that there's definitely we have a tight signature that has matched that shows that there is actually an area of your code that is open to attack and requires immediate action. You really should not ship the code with that vulnerability in place. By contrast, a security hotspot is a security sensitive area, something that you might want to take a second look at just to make sure that you haven't done something inadvertently that could cause a security issue for the application that the code is running. So there's obviously a lot more hotspots and there are vulnerabilities. You'll see on the slide here that we found 8.4 million hotspots compared to 1.3 million vulnerabilities, right? So you would expect there to be fewer vulnerabilities found, and that's the case. All told, across vulnerabilities and hotspots, if you do the math, it works out to about 1 to 2 security issues per developer per month, which again was quite honestly quite a bit lower than I thought it would be. I know I screw up more times than that in a week, so you developers must be a better breed of human than me. And with that, I am going to pass it over to Lauren to take us through the top vulnerabilities we found and the top hotspots we found and the security. So Lauren, over to you.
Thank you, Nirban. And I have confidence that you are just as capable as our developers joining us today.
Thank you. Appreciate it.
So thank you all for joining us. As Nirban said, I'm going to walk us through the vulnerabilities that we find most often across these common languages. A lot of these different vulnerabilities apply across many languages, but there's obviously nuance in how the solution works at the language level. So just a level set here for anybody who's unfamiliar with SonarQube, we have an extensive rule development process that's going to test our language analyzers extensively. We do a lot of testing of new rules before we deploy those into the product. Once a rule is deployed, developers can start to see issues raised in their workflow. They can still flag an issue as a false positive, and that actually triggers an internal review and validation process. So really appreciate when folks do flag those things. And so, send us your edge cases that we may have missed in initial development. It helps us to have this feedback loop going with developers to continuously make the product better and better and more accurate and focused when we think about vulnerability-based risk. Next slide, please. So our number 5 issue that was detected here is the weak SSL TLS protocol should not be used. So encryption algorithms are essential for protecting sensitive information and ensuring secure communications. Developers are going to use this technology to protect all kinds of information that's running throughout the application or back and forth between the application and the end user. An example attack scenario here would be when a website doesn't use or enforce strong encryption. An attacker can monitor network traffic, can find insecure points, downgrade connections from HTTPS to HTTP, intercept the request, and now they've got cookie session data, and they can start to do nefarious things with that. So a lot of developers might assume that languages have, modern libraries handling encryption well baked in, and that they don't need to do much more beyond that. But we do see that there are deprecated protocols out in use in the wild, things like TLS 1.0 or 1.1, SSL 2.0, 3.0. And these older versions have known serious flaws. So, they've been demonstrated as attack vectors and proof of concepts. And again, an attacker could actually use this to launch a sort of man-in-the-middle attack. So this isn't just hypothetical, it's a direct violation of compliance standards like HIPAA for healthcare and consumer data, and then things like PCI compliance for payment processing. So what you're seeing here on the slide is actually how we show a developer that they've got a violation of this rule. And we start to give them some education about what the problem is and why it matters. So we move to the next slide. What you will see is how we guide developers in the product to make better secure coding decisions. So again, developers have choices around which encryption tools and versions they use. So, our job is to stay on top of this and protect them from deprecated versions that have been proven as unsafe. I don't know if anybody's here has heard about the emerging risk with quantum computing and how there are new affordances that are going to be around for breaking encryption. So there's a lot of effort globally right now in educating the industry on, what to get prepared for. And you can rest assured that we here at Sonar are staying on top of things, and we are actively monitoring things and always adapting our rule sets to stay current and keep your software safe. Next slide, please. We will move to number 4, which is SQL injections. Who here remembers when Equifax had to appear in front of Congress to explain how the personal data of nearly 150 million people was breached and then eventually leaked? This is one of many types of downstream impacts of this attack. This is just a well-known example of this type of vulnerability. In the case of Equifax, what actually happened is the weakness was in the open source library, Apache Struts. Apache Struts had issued a patch to fix this, but the Equifax team was not able to apply that fix in a timely fashion. We also have, I saw a question come in about our new advanced security capabilities, and we now have the ability within SonarQube to trace and track when a vulnerable release shows up that you may be using. So you've got extra protection there. Your team would know, hey, it's time to update struts. This is a very serious remote code execution vulnerability in that case. And here's how we're going to help you make that change. So this is one of the most old and kind of most dangerous vulnerabilities. Attackers can inject malicious code into a query. It bypasses authentication, can retrieve data out of a database, wipe your database clean. It could have pretty catastrophic consequences, leading to that theft of customer data with the example that I gave. But even intellectual property or trade secrets are really at risk here. Essentially, at its core, it's just a fundamental failure of input validation. So you can see here on the screen where we're showing in the product the line of code where this failure of input validation exists. And what you see here is we're showing not only in the tabs how the developer can fix it from a sort of theoretical perspective, but you can also hit our handy Generate AI Fix button here. And if we progress to the next slide, please. You will see, I think our next slide actually has the theoretical sort of textbook, how can I fix it? But if we could go one more slide forward, you'll see the generated AI fix that is taking a look at their actual custom code. It's giving them the line of code, how the fix should be implemented, and that fix is ready to push out to secure the application. And now there's no longer a query that's going to use direct input from the user and open that door. So it's important, obviously, to remove this kind of risk from the code. The easier and faster that we can make this for developers, the better. So that's our number 4. And we can move on to number 3, which is endpoints should not be vulnerable to reflected cross-site scripting attacks. So cross-site scripting attacks target users, not the server itself. An attacker injects a malicious script into a legitimate website. When the user visits the site, the script then begins to execute in the user's browser. And it allows, again, the attacker to steal cookies, hijack user sessions, or redirect them to a malicious site. In particular, in the age of AI, things are getting easier and easier to spoof. There is, an ability to fool just about anybody these days with a malicious site and start to get them to even input their own information and leak that way. So this is going to cause chaos, risk, reputational damage as users are compromised on the sort of website that this is happening on. In 2024, there was a hacker group called Resume Looters that leveraged a combination of cross-site scripting and SQL injection to steal the personal data of job seekers. So this is, kind of an example of where the dominoes can start to fall, even with just a simple kind of front-end attack. If we go, so again, here we're showing the developer exactly what's happening, and we've got our generate AI fix. And if we go to the next slide, you will see an example from the product of a recommended mitigation pattern, as well as the actual fix that's ready to push out. These kinds of attacks have happened across all kinds of industries, airlines, online gaming, and really the downstream effects that we've seen over time are very, very costly data breaches. So even in 2025, this continues to be a top concern. It's on the OWASP top list of vulnerability risks, and it continues to reinforce that need for a scalable education and enforcement solution like SonarQube. Next slide, please. We will move on to exceptions should not be thrown from servlet methods. As you can see here, this one's only for Java and our Java servlets. This might seem like a minor bug. I started my career in Java programming a very, very long time ago, and I would have thought of this as kind of a nice to have at that point for better formatted user error messages. And it can be that, but it is also actually a security risk. So the good news is I haven't been a software developer for decades. So these might seem like a minor bug, but they actually are a major security risk. When an exception isn't handled properly, you can crash the application and you could display a detailed stack trace to the user. And so that could have sensitive information in it. It could have information that allows the attacker to start creating almost like an architectural blueprint of your application, making it easier for them to then find and exploit other weak areas. So this could be another kind of first domino in a larger scale attack. So what you see in this example here on the screen is that the developer has put in place a catch block, but what's happening in that catch block is just another exception being thrown that's not properly caught. Next slide, please. So what you're seeing here is showing and teaching the developer, ensuring that we've got gating in place to properly catch these clauses. Again, more than just a well-formatted error message, they are actually a critical security measure. And our number one, the number one volume of vulnerabilities that we found in this research are the log injection vulnerabilities. I don't know if anybody remembers maybe what you were doing over the weekend of December 9th, 2021. If you were involved in security, IT, even compliance that weekend, you were probably spending a lot of time looking for where in your organization you were using the open source package log4j. And you were looking to find where were you going to need to go into an emergency patch management process. So log4j is an example of a place where this vulnerability existed. The attack vector was available to inject information, and this would allow you to hide activities in the log, overwrite the log, etc. This is a very broadly used open source package in industry, so there was quite a scramble and a December to remember around that. So This was a painful, expensive moment. Again, it was more about the usage of an open source library. But this can also be something that your teams are doing in the first party code that they themselves are writing. So important to keep an eye out for this type of threat vector. Again, this is about being able to overwrite or obfuscate things in the logs. And it really comes down to not sanitizing data that the user is inputting. So on our next slide, we see our AI generated solution that's ensuring developers are going to use sanitized, typed, and otherwise validated user input data before it is logged. This particular solution is looking for carriage feed issues, line feed issues, carriage return issues. So, further actions could be required depending on the specific context there. But again, good to have this in place so you're doing this continuously and at scale. So those are our vulnerabilities. And now we're going to shift to the top 3 most common hotspots. As Anirban said up at the top of our hour here, the difference here being anything that we are actively calling a security vulnerability issue is defined and validated, and setting aside any very edge case scenario of a false positive, this is a real vulnerability that needs to be addressed. A security hotspot has a less degree of certainty, and it really requires manual intervention to ensure that context is introduced. So you got to bring in your business context to know what kind of application we're talking about, what are the details around the scenario. These are places that could be highly susceptible to attack, but they also may not be. Central to our philosophy here at Sonar is ensuring that we keep the noise down for developers. And so this is a place where we ask for partnership with our security teammates to help us determine is the threat real and active and present on this. Next slide, please.
Actually, Lauren, before we go to the next slide, we've gotten this
Sure.
question a couple of times already in the Q&A. I thought it might be good to just address it now. And it's applicable to both hotspots and vulnerabilities. And the question is, like, what parts of the analysis and issues that we are flagging today as part of this analysis our requirement is to have advanced security in order to see them, or can you see them in the core product? I believe everything is detectable by the core product, if I'm not mistaken.
Yes, that's correct. Yeah, everything today that we're looking at on screen here is all part of the core product. What's available in advanced security is some pieces around the open source library management. So we're not seeing any screenshots of that. I just wanted to use a couple of stories there to illustrate, different types of attacks. So everyone remembers Log4Shell.
Yeah, so basically every vulnerability and hotspot that you're going to see in the presentation today is detectable by our primary SonarQube paid offering. So you don't need to have advanced security in order to see any of this.
Yes,
all right.
That's right.
Thank you very much.
Yeah, of course. Okay, so number 3 hotspot here, using slow regular expressions is security sensitive. So a regex backtracking vulnerability happens when an engine gets stuck in time-consuming, computationally expensive process. This can be, injected using a specially crafted input string, and it leads to basically a denial of service attack. And this one's interesting, and this is, again, available in the core product, but it does lead to sort of an observation about our increasingly interconnected software supply chain and the security around that. So there was a vulnerability disclosed in 2024 affecting a popular JavaScript library, OctoKit, and it was actually caused by this kind of threat. A regular expression was used for parsing URL paths, and it was found to be vulnerable to this kind of backtracking attack. And what happens, there when it's in an open source library is then you've got a downstream service outage for applications using that library. So again, you want to be sure in the core product that you're eliminating or just, being very certain about this kind of risk in your own software that your developers are writing. This attack was really simple to carry out. There's no special privileges or interaction required to do this. It really just requires sending a single specially crafted request to trigger this kind of service level outage impact. So this is our number 3 that we found in the software we observed. Next slide, please. So number 2 hotspot, using hard-coded IP addresses is security sensitive. This may seem benign. It may be something that shows up in our source code when we're early in the software development lifecycle. Maybe we're testing things and flipping from environment to environment, or things like that. But this is actually creating a brittle, insecure system if you retain these things, or it could be. So if you hard code the IP address of a database, as an example, you're going to lose flexibility and security. So if the IP address needs to change, then you're sort of stuck hunting this down. And then also different readily available network mapping tools can take something like this and launch a man-in-the-middle attack, spoofing an IP address to bypass security checks, etc. So again, this is a hotspot that we would want to take a look at. And if we flip to the next slide, you can see again this developer education approach where we're explaining that we want to leverage a better solution like environment variables as a best practice. So even if there's context used to determine that this is not a credible active threat, it's still, I think, good in service of developer education and improving the overall security of your code to be able to find these things. It can be easy for sensitive information that's hard coded to slip into a production release, and you don't want that getting out there. All right, our number 1 hotspot is hard coded credentials are security sensitive. So sort of escalating from IP addresses now to credentials. This is a very common, dangerous mistake that a developer can make. It's easy to extract strings from an application source code or binary, and so you do not want to be hard coding database passwords, API keys, etc. Once these things get put in, they are no longer your internal information. They're no longer secret. They can be found by anybody who can access the code repository. There's many examples of this happening where something accidentally was pushed out to a public GitHub repository. And once that credential is leaked, it can be used to shut down your production systems, steal data, etc. So if you think about how many developers you may have actively working on your application where credentialing information is required for different connections, and you think about how easy it is to push code to a repository that may be visible, from the public, you can understand how just simple human error can create a pretty large catastrophe quickly. Nobody wants to be on the front page of the news for this kind of thing. So this is a simple way to monitor and manage these types of hotspots. If we go to the next slide, I think we are just showing here again, what would we guide developers to do? So, any type of review scenario where you're looking at this hotspot, you want to be asking, do our credentials allow access to sensitive component like a database, API, or service? Are they used in production environments? Is application redistribution required before updating the credentials? And so there's risk here if any of these questions are answered with a yes. Best practice here, store it outside of the code repo, change it immediately if a leak of this is discovered. All right, we are going to move on to the biggest secret now. Actually, I think we have a poll before we're going to do the secret, if we want to flip to that. So we are asking here, what's the most frequent type of hard-coded secret that SonarQube detected? We've got AWS credentials, database passwords, Azure storage keys, and OVH keys. This is when we need our Jeopardy music in Nirban.
We do need that, yes. Maybe for next time.
Just give it a little more time here. There we go. All right, 66% say database passwords. If we flip to our next slide, we can confirm that this is in fact true. 50% of the secrets found by Sonar were associated with database passwords. Any security professionals on the call now, I hope you're not having too much heartburn. The database, single most valuable asset in most technology companies. It contains your customer data, your company financial records, your intellectual property. A hard-coded database password is the equivalent of leaving the front door to your house unlocked and an open door and saying, please come in. This is a really bad threat vector for an attacker to come in and take control of your data. The way that we detect secrets at Sonar is we use common regex analysis, which is used, throughout industry and in various tools. But we also have proprietary semantic analysis, code structure analysis, and taking a more context-aware approach allows us to differentiate between simple string that may be risky to a genuine hard-coded secret that poses a risk. This is a big part, this contextual analysis is being really sure is a big part of how we earn and retain developer trust with how we approach the product. So again, just continuing to make sure that we're doing our due diligence to not waste any developer time on things that may not matter. So I was going to hand it over to you and Nirban to talk a little bit more about what we're doing to extend the depth of those call paths.
Yeah, thank you, Lauren, and thank you for the presentation. So as you mentioned a couple of times already, there's the class of security issues that are literally in the source code that we're analyzing, and we've been talking about the frequent issues that come up in our analysis for the past few minutes. But there's another class of issues that arise from dependencies that you're pulling in. Either you're calling a function in an open source library, or you're pulling in some other dependency, and there could be issues that come from either that pulled in open source library or the third-party library having some kind of an issue in it, or the execution path of your code going into external code and coming back into your code, causing an exposure or a risk of a security nature. And so the good news is we have these advanced SAST capabilities and software composition analysis capabilities as part of our paid add-on for SonarQube called SonarQube Advanced Security. And this is something that we made available for SonarQube Server earlier this year. And this week, we've actually now added this support for SonarQube Cloud. So SonarQube Cloud customers are now able to access this paid expansion for SonarQube to get these advanced security features as part of their deployment of SonarQube. So what this basically allows you to do is highlight risks that might be in your code base due to other external calls that you are making to third-party or open source libraries that are out there. For example, if you're calling into an open source library that has been patched, there's some vulnerability that was found and fixed, but you're still calling into the older version, we will find and flag those issues for you. This also helps you with things like software bill of materials requirements, where you need to, for audit reasons or reporting reasons or compliance reasons, or just to know what's happening in your source code, all of the dependencies that you're pulling in, every time you're doing delivering a new module of software, we're actually able to help you collect those lists of external dependencies that you have so that you can fulfill your audit requirements or have just a list of issues to go address if you need to. So this has been available for SonarQube Server. As of this week, is now also available for SonarQube Cloud. I also wanted to quickly talk about our upcoming webinar. This is actually going to be an on-demand webinar that will be published next week of another piece of research that we did here at Sonar called The Coding Personalities of Leading LLMs. I mentioned at the beginning of this event how AI code generation has a risk of creating some of the same issues that we see in human generated code, because it's literally learning from human generated code to create the code that it's writing. And we got a couple of questions during the Q&A actually of like, well, if you're saying that AI code is dangerous, why are you using AI for code fix, things like that? And so the lesson or the message that I would say in response to that is not that AI coding is dangerous. It's actually an incredible tool. Many of you in the event today are already using AI in your day-to-day to write code, and you know how useful it can be for prototyping and for generating production code with the right guardrails in place. The only thing that we would say as a best practice whenever you're using AI-generated coding tools is to make sure you're running a verification step once you've generated the code, to make sure that the code in its entirety is still following all the best practices, is compliant with your rules and requirements, is not exposing you to undue risk of any sort, whether it's a uptime risk or security risk. So keep using those AI coding tools. They're going to get better. This is the worst they're ever going to be. They're only going to get better from here on out. And always make sure that you are verifying them with SonarQube or a similar tool to make sure that the code is safe to deploy into production, is what we would say. And so this research that Sonar is doing, both in terms of the state of code, the top issues that we see, and in the tendencies that LLMs have to have certain, maybe they have slightly less easy to maintain code. Maybe they have a propensity to hard code secrets. Whatever those issues may be, it is important for developers to be informed on what those risks are so they can better address them and better assure the code and make sure that it's high quality whenever they are done with it. So definitely keep using AI coding tools, but definitely verify the output of those tools using a tool like Sonar is what I would say. And this research on LLMs and the tendency that they have to write good or bad code is a very, very useful tool for you guys to understand how the different models that exist compare in terms of their tendencies to create, maintainable code, secure code, code that's bug-free. We actually have a deep analysis that we've done across, 5 or 6 of the top models that are in use today that we'll be talking about during this on-demand webinar next week. So please keep a lookout for that. And with that, I will pass it back to Andrew.
Yeah, thanks, Anaban. Thanks, Lauren. That was really good. And I just want to double check some questions. I know Robert's been working really hard in the background to answer all the questions, or as many of the questions as we can. But there was one I did want to just pose to you both, which was which vulnerability databases and registries, for example, CVE, CWE, does Sonar reference for its security analysis?
Lauren, you want to take that one?
Sure. Yeah. So this everything that we focused on today is leveraging kind of best in industry frameworks like the OWASP top 10 lists, CWE frameworks, and then our deeper proprietary taint analysis and even our own original security research. So those are going to generate all the kinds of issues that we were looking at. From an open source software perspective, we're using the National Vulnerability Database, osv.dev, which aggregates things from GitHub security advisories, other sources. And we use first.org's exploit prediction scoring system, EPSS algorithm, to determine the likelihood of exploitation in the next 30 days. And we also use the CISA known exploited vulnerability list as well. We finally, for the open source perspective, we also have partnerships with open source maintainers who do a deeper postmortem review on a vulnerability. So the intent of that model is to give customers better information when they're remediating an open source vulnerability, and also invest more into open source. We have fewer issues like a log4shell moment that attack those upstream packages.
Great, thank you. Another question we had was, I think I think Anaban, you were talking about AI code fix, and the question revolves around that, which is, when Sonar uses AI to suggest fixes, remedies for bad code written by AI, wouldn't those fixes also have issues inherent to AI? Bit of a convoluted, long question, but I think you get the intent.
Yeah, absolutely. So yeah, we are very aware of the risks that can happen when AI code is being used, which is why we've advocated verifying all the output in the first place, and that's something that we actually take very seriously at Sonar. You'll find that there are some issues. I think the most issues where AI code fix is actually turned on, it's because we have done a lot of testing in our backend to make sure that the fixes that are being generated by the LLM are high quality fixes that actually solve the problem and would obey most of our quality checks. And so when we are actually prompting the LLM for the response, we are actually making sure that we provide all the context that the LLM needs to generate a fix that is actually going to work and be a smart, high quality fix to go in. And if we are not able to be confident that the fix to the issue is not going to satisfy that criteria, we just won't flip code fix on as an available option for those rules. And so we've gradually over time been flipping on. I think code fix became very available, if I'm not mistaken, at the end of last year. And but it was only a small subset of rules at that time. And since that time, we've just been flipping on a few rules here, a few rules there to just increase our coverage over time as we become more confident through our testing and prompting that the fixes that are generated by SonarQube are actually going to be fixes that you would want to put into your code.
Thanks, Anirban. Another question, and I think you touched upon it earlier on in the webinar, but the distinction between the issues that SonarQube would find versus the ones where you might need to use the advanced security to go a bit deeper. Is it possible to just touch upon that again and make it crystal clear where the two sit?
Yeah, Lauren's the expert. I just gave a high level. I'll let you take this one.
I was going to say it might even be helpful to flip back 2 slides to show that maybe a little iceberg again. Great. So here you can see core security is really kind of the top of the iceberg surface area. So again, this is where your developers are either writing code themselves or generating code from AI themselves, and this is showing up in your code repository. And that's going to cover the static analysis, vulnerability, and other types of issues that we walked through today, your infrastructure as code issues, your secrets. And then what happens below that iceberg is what is falling into advanced security. And that's really where first-party code starts to abut against third-party open source code. So for advanced static analysis techniques, that's going to involve much deeper sinks and taint analysis, tracing those call paths to actually find vulnerabilities that aren't necessarily, or they aren't registered in the common vulnerabilities exposures database yet, the CVE database. And then on the SCA front, we are doing the manifest-based package analysis to correlate a certain release of an open source package with vulnerability risk, and actually in this case, licensing risk, for your organization as well. So that's really where that line sits, is everything above the line is what's happening in the code you wrote, and everything below it is what happens when you start interacting with open source libraries.
Great. And if I'm a SonarQube Cloud user, for example, and I'm interested in advanced security, how would I get hold of that? How would I be able to leverage that?
You can leverage it now. We actually just launched that on cloud this week. So on the website, there's a URL which we can drop in the chat and follow-up email where you can get going on a trial of that, and would love to hear any feedback on it from folks. And that's about it.
Excellent. So it's an extra subscription to the paid SonarQube Cloud or SonarQube server. Okay, fantastic. Really, really good stuff. Thank you so much. Thank you for everybody that did ask questions. I think we will drop that link to the advanced security in the chat, as there have been a lot of questions around that today. So do check that out. As Lauren says, you can take a trial of that, so that's useful. If there are any questions that we didn't get a chance to answer, or you didn't actually think of until this very last moment, please use our community. It's a great place, our community forum, to place further questions, and you'll find lots of already answered questions as well that you can refer to in our database. And finally, thank you for completing the survey that will pop up shortly as we conclude the session. And last but not least, thank you to Anirban, thank you to Lauren, thank you to Robert behind the scenes, and thank you to all for joining the webinar today, and see you next time.
Thank you, everyone.